Number 7. What do you know about number 7? Chloe? Good. These two arcs are equal to each other. What's the reason that those two arcs are equal to each other? They're across from each other, which means because these two angles are vertical angles, those are equal, which means their arcs are also equal to each other. Because we know that a central angle is equal to its arc, which means all 4 of these things are equal. So I'm going to do 10x minus 22 equals 8x plus 12. How do I solve this? Good. Add 22 to each side. And I heard you say move the 8x. How would I move the 8x? Subtract it. So 2x is equal to 34. Carla, what do I do now? 2x equals 34. Divide by 2. Very good. And we get x is equal to 17. All right, so I'm going to zoom out a little bit. X is equal to 17, but we also have these other blanks to fill in. You need to be careful on your mini test because some of them will ask you for the variable and some of them will ask you for the arc measure. Please make sure you know what it's asking you. What do I do with the 17 to find the measure of arc AD? Good. Plug the 17 in for x. So 8 parentheses 17 plus 12. What does 8 parentheses 17 mean? Multiply. Good. So that gives you 136. What's 136 plus 12? Very good. 148, which means the measure of arc AD is 148 degrees. CD is not one of those two arcs. CD is right here. I think I heard a correct statement. Can you say that one more time? 180 minus 148. So AD or AC is a diameter, so is BD. So if this one is 148, then AC is a semicircle, halfway around equals 180. So you're going to subtract those. What do you get? 32. Very good. 32 degrees for the measure of CD. All right. BDC. Should I go to the right or the left when I start at B? The left, because in alphabet, or not in alphabetical order, but in order of the letters, B, then D, then C. All right, well, we know that this one's 32, right? And this one's 32 because they are vertical. These are vertical angles here, so they're equal. So 32 plus 148 plus 32 will give you your answer. Or you can take the full circle and subtract this one over here, which should also equal 148, because these match. All right, I'm going to add those 3 up instead. So BDC, 32 plus 148 plus 32. What does that give you? 212. 212, which is our answer for that last blank. Questions on the front side? Okay, flip over to the back. Okay, an inscribed angle. So on the other side, we learned that the central angle had the vertex on the center. Does this have a vertex on the center? No, my vertex of this angle is B. Where is the vertex? On the circle. So please write on the circle. Those two sides of your angle are called chords. So AB is a chord, BC is a chord. All a chord is a segment with endpoints on the circle. So what are the endpoints of AB? A and B. Okay, the endpoints here are on the circle. That's all a chord means. A diameter is a chord that goes through the center. That is the only chord that goes through the center is called your diameter. An intercepted arc is an arc that lies between the endpoints of your angle. So see this angle here? The endpoints here are A and C because we would write the angle as A, B, C. Your endpoints will be your first and your last letter there. So the intercepted arc is the arc that lies between the endpoints of an inscribed angle. Okay, so if you think back to your activity that we talked about this morning, which one was larger, the angle or the measure of the arc? The measure of the arc. So when it says the degree of the inscribed angle is equal to how much of that arc? Half. Half the measure of the arc. So we can also write that algebraically. The measure of ABC would be 1/2 the measure of arc AC. Questions? Okay, we're going to talk about these next two. You should be able to solve these based off of the information that you know, but we're going to talk about them so that they look familiar to you. An inscribed angle that intercepts a diameter has a special answer. You can solve for it because you should know how much that arc equals. So here's my arc, my intercepted arc, because the endpoints should be B and C. So the arc is BC. What is the measure of this arc on the outside? 180, because it is a semicircle. If the angle has to be half of the arc, what does this angle equal? Half. If the angle is half of the arc, what does this angle equal? 90. So what do we call 90-degree?
Right angle.
Yeah. 90-degree angles are right angles. So the measure of that angle is 90 degrees. That's just a special case. So you can see right triangles inside some circles. Another special case is this next one. Okay, so it's talking about angle ABD here. What are the endpoints of ABD? A and D. So we're talking about arc AD. What other angle has those same endpoints? What other angle has A and D as the endpoints? ACD. That means the measure of those two angles share the same arc, which means those two angles will both be half of that arc, which makes those two angles equal to each other. That makes sense? All right. We're going to just do some practice problems. Which is bigger, the arc or the angle? The arc. So what do we do with the 62 to find the angle? Divide by 2. So the measure of WXY is 31 degrees. Which is bigger, the angle or its intercepted arc? Always the arc. So what do we do with the angle to get the arc? Multiply by 2. So the measure of DGF is 226 degrees. Okay, this one's a little harder because we have several angles that we can look at here. But let's look at the one it's asking for. PQR is here. What are the endpoints of PQR? P and R, which means we need to look at arc PR in order to find our answer. What does that arc equal? How do you know it's 180? It's a semicircle, half of the circle. So, which is bigger, the arc or the angle? The arc is bigger. What are we going to do with 180 to get the angle? Divide by 2. Very good. That one's a right angle. So just like the one we did up here, intercepting a diameter. Are we ready for number 4? Okay. Which one's bigger, the arc or the angle? The arc. So what are we going to do with 47 to get AC? Times by 2 because we're going from the smaller one to the larger one, which gives you 94. Now here is where you need to take a minute and pause before you just keep multiplying and dividing. Do we have the answer to this problem yet? No. We have the intercepted arc, which is AC. You want to find BC. How do we do that? Good. 180 minus 94 should give you 86. Yep. 86 degrees. Next one. We're looking for JKL. JKL is this angle inside here. That angle corresponds to this intercepted arc because our two endpoints are J and L. I need to find that arc before I can find the angle, so you're going to have to do a couple steps here. How do I find this arc? What's a full circle equal? 360. What do I do with 360 to find this arc here? Subtract 65 and 53. What do you get when you subtract both of those? I think I heard it. Someone say it? Okay. You can use your calculator. That is correct. 242. Was that my answer? Yes? No? No, because we want the angle here. Is the angle bigger or smaller than that arc? Smaller. So we divide by 2. You get 121 degrees. How we doing? Okay, we're going to do number 7, and then we'll be done. Okay, number 7 requires a little bit more algebra. Which one is larger? The arc. So what are we going to do with the arc to get that angle? Divide by 2. 158 divided by 2. 79. 79. Okay, so if this angle CDE, the measure of that angle equals 79 degrees, what do I do to solve for x? Good. 8x minus 9 equals 79. We are going to add 9 to each side. And what does x equal? 11. Sometimes it will ask you to plug x back in and solve for something else. So please make sure you're following the directions. But this said solve for x, and we got that. Okay, your homework's on the board. You can get started.